Welcome to Video Lecture 7.1, Geomorphology. This is a good introduction for not only Video Lecture 7 and all the contents that follow, but also Video Lecture 8. This here is the hydrologic cycle or the water cycle. Simple idea. Here's water on Earth. It's a constant. We only have so much of it. But the key characteristic is it moves in different states. And so, of course, in our oceans, our large water bodies, we're going to get evaporation. And with evaporation, we're going to get water turning from a liquid to a gas in the form of water vapor. Of course, we've talked about precipitation. Of course, with precipitation, when we can move that water that's being evaporated from the oceans, our large water bodies, over land. And then at that point, we get then water falling in the form of condensation, i.e. precipitation falling down to the surface. From there, we get the water that filters through the surface. We refer to that as infiltration or percolation. But then also we've got water that flows on the surface. We can think of that as surface runoff or just essentially streams, rivers, creeks, what have you. Further, trees, they are also a key part of the hydrological cycle. Of course, they soak up water, especially from that top layer of the surface, and so they soak up that water, and then they perspire that water on their leaves, and eventually that water on the leaves is going to evaporate as well. So this whole idea is water moves in a cycle, in various forms, various states. Many of the current processes that influence landform change are due to those same temperature and precipitation characteristics of areas that we talk about in the Exam 2 content. And so once again we have the idea of this content building and building and building. So one of the things we're going to talk about is weathering and erosion. And that's key to understanding that is that's where we have the atmospheric influences of temperature and precipitation now reacting with that underlying surface that we mentioned and described in Video Lecture 6. So we have that underlying bedrock, also referred to as parent rock, which is exposed to these atmospheric influences and thus going to be softened and broken up into smaller bits of rock, which is called regolith. Regolith is that layer of mineral particles that are above the underlying bedrock, and so essentially it's broken up bits and pieces of the underlying bedrock due to the atmospheric influences. And so one of the things we'll talk about here in Video Lecture 7 and 8 is the role of regolith being the source for much of the sediment that is moved, eroded, and transported and deposited in other places. And so we think about what moves it: moving water, rivers, moving air, wind, moving ice, glaciers. And so I mention this now because this is going to be something we're going to come back to time and time again. Now let's try to get a snapshot of the role of that water, that precipitation that filters through and feeds our underlying groundwater, which I mentioned before in the hydrologic cycle. So here we have the gray globs illustrating regolith, and at the bottom we can see bedrock. The brown indicates mostly soil, where the blue indicates mostly water. And so one of the things you'll notice, there's two distinctive zones. And so here we have rain falling. It's going to work its way through these various zones, and it's going to settle at the bottom. Why is it going to settle at the bottom? Gravity's pulling it downward. And so one of the things you'll note is just like a cup. If I pour water in a cup, of course, it's not going to come out of the bottom. And so essentially that bedrock is what we refer to as an impervious surface in which water cannot penetrate through it. So essentially that water is going to be stored and held just above that underlying impervious surface. And so the first thing we'll talk about is the zone of aeration, that at the top. And so water works its way through the zone of aeration, but eventually is going to collect in the next zone that we're going to talk about. And so one of the things you'll note here is the pore spaces, or the spaces in between the bits and pieces of regolith, is mostly air, soil, organisms, what have you. So we'll also refer to this as the unsaturated zone. Much like a Brita, if we think about a Brita is a water filter, filters out your water. You put the tap water in the top, and then the Brita filters out, and the water collects at the bottom. Same idea here in our zone of saturation. Here the pore spaces are going to be more contained with water, overwhelmingly water in the pore spaces in the bits and pieces of regolith. We also refer to this as the saturated zone here. And so the simple idea here is the top of the zone of saturation is known as the water table. One of the things to note about the water table, it generally follows the contours of the surface, roughly. We can see that surface up there with those poorly designed trees, that green line near the top. Well, of course, groundwater flow, as far as how fast this underlying water flows, is going to depend on the steepness of the slope, i.e. gravity. Now I've taken those schematics, those models on the previous images, and I've taken them to maybe more real-life example. One thing you'll note here is, of course, we can see the zone of saturation, the water table, the zone of aeration. You can also see how the water table, for the most part, follows the contours of the surface. But more importantly, if we look at the surface stream. So essentially, anytime you see a river, a creek or a stream, for the most part, that is simply the water table exposed. The water table is exposed and it's above the actual surface. And so a surface stream is just the water table exposed. One thing that does occur during a dry season or even a drought period is the fact that the water table is going to lower. And of course, during a wet season, that water table would then rise. Now let's hit you with some definitions. First off, geomorphology. Geomorphology, if you know anything about etymology, geo, earth, morph, shape. So it's the study of the shape of the land, essentially. So this is essentially the science of landforms. Of course, geology very much overlaps with this, but geology is a little bit more concerned with the surface and below and more of the kind of the basics, the fundamental ideas as far as what created that landform. We're going to be more interested in the surface and above and how humans have to adapt to these various landforms, to the shape of the land. We're going to be focusing in on a key term, landform denudation. Landform denudation essentially is any process that wears away or changes landforms. Beforehand, in video lecture 6, we talked about processes that create landforms, that build them up. Now we're going to be talking about things and processes that wear away or change landforms. And these begin with weathering, which we'll talk about here in video lecture 7, mass movement, which we won't really talk about here because in Indiana we don't really have this as big of an issue because mass movements, think of it as landslides. It's going to be more of a key issue out west and where places where you have steeper slopes, mountainous areas, what have you. But in Indiana, we really don't have much of a mass movement issue. But erosion, we're going to look at the various processes of erosion, essentially the removal of sediment, the removal of Earth's surface material, and of course that removal, that sediment has to be moved somewhere else, transportation, and eventually that sediment, that process that moved and transported that sediment eventually is going to leave it, lay it down, and we call that deposition. Now we defined weathering. Weathering is the disintegration of rock exposed at the surface due to atmospheric influences. This is not erosion, this is not transportation. This is essentially the breaking down of rock so that it can then be transported by the various processes that we'll talk about later in video lecture 7 and all of video lecture 8. So this is not the transportation of this weathered away material. Transportation, that's going to be erosion, gravity, or the various transportation agents we'll talk about a little bit later on. So that's going down. That's in the future. We'll talk more about that stuff later. But in terms of weathering, I'll come back to those key terms I talked about right at the beginning. Bedrock is the parent rock from which weathered regolith or broken up rock and soil develop. One thing to know is bedrock varies from place to place. The regolith is then subsequently going to vary from place to place. And so some rock is sturdy rock. Some rock is like the Chuck Norris of rock. It's hard to break it down. Where others are a little bit more softer, a little bit more capable of being broken down and weathered away. So we think about the underlying bedrock. It depends. As far as the rate of weathering is going to be contingent on the atmospheric influences as well. So we can think about weathering being influenced by the climate, the water table, slope, the underlying bedrock. Is it hard? Is it soft? Is it being capable of being broken down with water? Is it not? All of these ideas, all of these, regarding weathering, all of these potentials are based on the characteristics of the underlying bedrock. There's two main types of weathering. They are physical weathering and chemical weathering, both of which we'll talk about in the next two video lecture sections. Typically, although they're two separate things, typically they work hand in hand together to help break down our underlying bedrock in regolith.